Welcome to Jay Cooper Smith's 10-minute networking workout. What a mouthful. But this is my first attempt to using social media for instruction, so bear with me while we go on this journey of being able to explore information technology. Like any good story, it's always good to begin at the beginning. So I'm doing a series on the introduction to numbering systems and the different types of numbering systems that we will be going over. Throughout history, we humans have used numbering systems to communicate different values and be able to cohesively explain what we're purchasing, not necessarily purchasing, but how do we count things in the calendars and how to keep track of stuff. So it's pretty much numbers have become a language of their own. Uh, as you can see, the Roman numbering system uses a series of I's, V's, X's, L's, and C's. They never really had a zero or a numerical representation of zero. Same thing with the Greeks and the Egyptian and Babylonian numbering systems. They never had a real way of expressing zero. It wasn't until the Mayan numbering system that they actually had a value for zero. Now, I got to give credit where credit is due. So here's a link on a lot of the historical numbering systems. Very good resource that I've used in the past, and it's always interesting to see what different countries and different eras of human history have come up with communicating numbers to each other. Now, in today's society, we use numbers all the time, and it's just a matter of how we represent them. So if we start off with a simple 2 and a 5, right? That just really doesn't mean anything at this point in time, with the exception of if I put, let's say, a dollar sign in front of it, then we know, hey, that's $25. So it is what it is. But if I put let's say January 25th in front of it, then that means a date to me. If I put, let's say, a 10 hyphen 15 hyphen 25, that's probably the locker combination type of thing. So we can do different representations, but that number doesn't change. A 25 is a 25, $25. I could even put a 10 colon. Now it's 10:25, so it's the exact minutes. What I find interesting is the only time that I've seen that 25 doesn't actually represent a 25. And you may come up with some other example, so I look forward to you guys responding to YouTube and telling me where you've seen that the number 25 doesn't actually represent 25. But the funny thing is if I put a square around this, and then I put the word speed, that for some reason in human nature doesn't mean 25. I mean, especially in America, that may be anywhere between 28, 30. You know, there's always a fudge system there. So that's the only time that I've actually come to realize that 25 doesn't really mean hard and set 25. So, what kind of numbering systems do we use in computers? Well, by all means, since this is information technology, we're going to learn about the numbers used in computers. So we're all pretty much familiar with the decimal system, but I'm going to have a video series that's specifically towards the rules and how to use the decimal system. But binary is by and large what we use in computers. Binary does come in two formats, and it's just basically how we binary is binary no matter what. Don't get me wrong, but it's how we represent binary. There's what's called a nibble format where you put it in 4 binary decimals and then a space and another 4 binary decimals. And then there's what's called octal format, which is 3 binary numbers separated by a space and another 3 binary numbers. And it all depends on how you want to represent binary. But as you can see, as we go down the list, the actual binary position and number that's in that is exactly the same. It's just how we represent it. So if you ever happen to have a quiz or something like that that says, hey, I want it in nibble format, they're talking about using 4 binary digits representation before you add the space. In octal, it's base. Well, we'll talk about base systems once we get into the specific octal and hexadecimal and how to manipulate those. Okay. Some very basic general rules of numbering system is there is traditionally a low value and a particular placeholder. In computer systems, that value is always going to be 0, whether you're talking about decimal, whether you're talking about binary, octal, or hex. The lowest value in any place is always going to be 0. Now the maximum value actually changes depending on what numbering system you're talking about. So like in the decimal system, the one that we're used to, 9 is the maximum value. In binary, 1 is the maximum value. In octal, 7 is the maximum value. And in hexadecimal, F, as in foxtrot, is the maximum value, which we were going to go over some more series videos on that one. Once the maximum value is reached, whatever that maximum value is, you use a placeholder and you increase that number on the placeholder and you start back at 0 essentially. So that is kind of an introduction to my numbering systems and seeing if this social media is going to be successful or not. Hopefully you've enjoyed it. I like to keep them very short and concise so that you can skip to wherever you need to go. I hope you've enjoyed this 10-minute networking workout. Thank you.